Welcome to 10.1, lines and segments that intersect circles. So this may seem kind of silly, but there's very good use of understanding these diagrams. So we all know what a chord is. Chord is also a diameter. By definition, a chord connects 2 points on the circle. Well, so does a diameter. The specific name for diameter is the way it is because it goes through the center of the circle. So we don't call a diameter a chord. Technically, it is one. All right, so now we have radius, goes from the center to any point all the way around the circle. Okay, and then the new ones are tangent. So tangent, a tangent line intersects a circle at only one point, and it's perpendicular to the radius and the diameter. Okay, so a secant intersects at 2 points. So these are all very important to remember. All right, so now coplanar circles and common tangents. Basically what we want to know out of this is you have different ways of writing couple circles. Circles intersect at 2 points. Two circles can intersect at 1 point. And there's two different types. So these are called tangent circles because they only hit at 1 point. And then you have no points of intersection. Obviously, they don't intersect, or they're just what we call concentric, one bigger than the other, but they have the same center of the circle. Okay, so make sure we know those definitions. Now, the tangent line to a circle has to be 90 degrees perpendicular to the center of the circle. So in a plane, a line is tangent to a circle if and only if it's perpendicular to the radius. External tangent congruence theorem. Okay, so now we're going to start getting into some calculations. Tangent segments from a common external point. So SR is tangent, is what it's saying. So it's saying that at point R, it's perpendicular, and at point T, it's perpendicular. So the tangent segments from a common external point are congruent. It says that these have to be equal to each other. All right. Name the circle. Well, we call it circle C. Okay? Circle C. Name two radii. Well, that could be CA and CD. No other radii there. Name two chords. Okay, so BH. And you can say HB again, but really probably AD is the other one. All right. Name a diameter, that's AD. Name a secant. Remember, secant hits at 2 points on the circle. So technically a diameter is a secant, but we want the line. Okay, so we'll say BH, line BH. Name a tangent and a point of tangency. So here's your tangent line. So you could say GE, and the point of tangency is point F. You also could have said FE, could have said GF, and vice versa. Okay, but the point of tangency is F. Copy the diagram, tell how many common tangents the circles have, and draw them. Okay, so a common tangent would be that one right there. Another one on the other side. One that goes in between them that hits at tangent points on each circle, and on in between on those. So there's four external tangents. Okay, two external and two internal there. All right, so on number 8 you have that one, and there are no other tangents, so there's only 2 on number 8. Number 9, there's only 1 tangent to both circles. And number 10, there are 0. No tangents at all. Now, tell whether AB is tangent to C. So what it wants to know is this perpendicular? So use the Pythagorean theorem. So number 11, A squared plus B squared equals C squared. Is that true? 36 plus 64 equals 100. Yes, it's true. So yes, AB is a tangent. So you do that on all of these. Number 12, A and B, so 9 squared plus 15 squared equals your hypotenuse squared. So 81 plus 225 equals 324. Well, 225 and 81 is 306. That is not equal, so no, it's not tangent. All right, so now is BA tangent. So these two are your legs because they're attached to what we hope is 90 degrees. And the 60 is your hypotenuse. So 20 squared plus 48 squared equals 60 squared. All right, so you take 20 squared as 400 plus 2,304 plus 3,600, equals 3,600. All right, so 2304 plus 400 is 2704. That's not 3,600. So no, that's not true, okay? Not tangent. So here's the one we think is tangent. So these two are the legs. So number 14, that was number 13. 12 squared plus 16 squared equals, now watch it, don't say 8 squared. 8 is this distance. This is your radius, which is 12. Isn't this your radius on top there? Let me erase this and show it to you again. Okay, so this is 12, so this must be 12. And this part right here is just 8, so the hypotenuse must be 20. So 144 plus 256 equals 400. So 144 plus 256 is 400. So yes, it is a tangent. AB is tangent to the circle. Now, point B is a point of tangency. So it's saying it is a point of tangency. So we're going to put 90-degree marks there. Find the radius. All right, so again, use the Pythagorean theorem. It's going to look a little ugly eventually. So these two are your legs. So r squared plus 24 squared equals r plus 16. And you got to square that. So r squared plus 24 squared is 576. And now you have r plus 16 times r plus 16. So that's r squared plus 16r plus 16r plus 256. So on the left we have r squared plus 576 equals r squared plus 32r plus 256. So now we get everything on one side. Let's subtract r squared. And thankfully those go away. So we have 576 equals 32r plus 256. Let's subtract 256. So 576 minus 256 is 320. And we divide that by 32, and we get r is equal to 10. That's your radius. Same thing on number 16. Those are your two legs. So r squared plus 9 squared equals r plus 6. And we have to square that whole thing. So r squared plus 81 equals r plus 6 times r plus 6. So we distribute all that, r squared plus 6r plus 6r plus 36. Barely got it on there. So we have r squared plus 81 equals r squared plus 12r plus 36. Subtract r squared, and thankfully those go away. They won't always go away. 81 equals 12r plus 36. So we subtract 36 from 81, and we get 45 equals 12r, and divide by 12, and we reduce 45 twelfths reduces by 3 to 15 fourths, which is 3 and 3/4 equals your radius. All right, number 17. All right, so r squared plus 14 squared equals my hypotenuse squared. So r plus 7. So r plus 7 times r plus 7 is r squared plus 7r plus 7r plus 49. So r squared plus 14 squared, well, let's just change that. That's going to be 14 squared is 196. 14r plus 49. Now it's just algebra. Subtract your r squareds. And we get 196 equals 14r plus 49. So 196 minus 49 gives us 147. And we divide by 14, and that's going to give us 10.5. So that's our radius. All right, there's our legs. R squared plus 30 squared equals r plus 18. And you got to square it. R squared plus 18r plus 18r plus 18 squared is 324. And this is r squared plus 900. So the r squareds we know are going to cancel out at this point. So we have 900 equals 36r plus 324. So we subtract 324 from 900. You get 576 equals 36r. So divide that by 36. And r equals 16. Now what they do wrong here, let's just figure out what, if this is, if this is tangent. They made it look like that's tangent, and that's probably what they did wrong. So this is supposed to be the tangent spot. So 61 and 11 should be your legs, and it should equal 60 squared, which, 60 is not bigger than 61. And that's what they did here. They took, let me erase this. They took the 60 and the 11 and thought that was the 90 degrees because that's what it looks like. Sure does. Okay, and so what did they do here? Because 11 squared plus 60 squared equals 61 squared, they're saying the XYZ is a right triangle. So XY is tangent. No, okay, so that's what they did wrong. They did put the two, 60 and 11, as legs and prove that this is 90 degrees. But in order for XY to be tangent, this angle has to be 90 degrees. So they misunderstood what was going on here. So XY is not tangent is the correct answer. Points B and D are points of tangency. All right, so they are tangent to the center of the circle, tangent to the radii. All right, and if they are tangent, then these two are equal. So 2x plus 7 equals 5x minus 8. So subtract 2x. 7 equals 3x minus 8. So we're going to add 8. 15 equals 3x. Divide off the 3, x equals 5. So it says find the values of x. So be very careful. Make sure you're checking what they're asking when you're done. All right, again, if these are perpendicular and it says they are, then these are equal to each other. So 7x minus 6 is equal to 3x plus 10. Subtract 3x. 4x minus 6 equals 10. Add 6. 4x equals 16. Divide by 4. X equals 4. Same thing. 4x minus 7 equals 3x plus 2. Just do the math. Subtract 3x. X minus 7 equals 2. Add 7. X equals 9. So 12x minus 5 equals 8x plus 3. Subtract 8x. And we get 4x minus 5 equals 3. Add 5. 4x equals 8. Divided by 4. X equals 2. Again, now we have a squared value equals 22. So we're going to subtract 4. Just do your algebra. 2x squared equals 18. Divide off the 2. X squared equals 9. So x equals 3. Positive or negative 3, but a negative 3 is not going to help you here. Okay, so number 28. These two are equal. 3x squared plus 2x minus 7 equals 2x plus 5. Anytime you can make a trinomial on one side of your equal sign, do so. So we're going to subtract 2x and subtract 5. Watch what happens. 3x squared, the 2x's are gone. We have minus 12 left. And now we can add the 12 to the right. Divide off the 3. X squared equals 4, so x equals 2. All right, so I wanted to point out that this is plus or minus here. You have to check both of these answers in order to say that they're negative. I'm not requiring you to do that. You will need to do that eventually. So be aware of that when you get to Algebra 2, and even some of these you're going to have to check. All right, good job.